Hello everyone, welcome to my channel. So in the previous video we saw what is distributed ledger technology is. So in this video we'll cover what is hashing in blockchain is. Okay, so first, introduction to hashing. So what does hashing do? It is nothing but it is a process of converting the input data or any file into some like fixed length hash value. Okay, this hash value can be even called as like a digest or a fingerprint. Okay, the conversion is based on like hash function. You can see input data hash function. Input data is given an input as to the hash function, and the output is provided as an hash value. Okay, so the like think of hash as a digital fingerprint. Like no two humans will have same fingerprint, like that only no two data values or any files, two different files will have same hash value. Okay, so hashing is not an encryption. Encryption is reversible, but hashing is like only one way. It is not reversible. Like once you hash an input value to a hash value, the hash value cannot be decoded back into the input value. Okay, this is what introduction to hashing is. Next is what is a hash value. See, suppose I'll give you an example here. We are using SHA-256 as an hash value. So hello is input to the SHA-256. SHA-256 is the word secure hash algorithm, 256 bits. Okay, so hello is the input to the hash function SHA-256, and the output is 64 hexadecimal characters. Okay, so this is how this is the hash value. This is the hash value of hello. So even like one character has been changed, that is like lowercase, and you can see the hash value is totally different. Okay, 50% of more than 50% of bits are different. So what is hash value? It is like characteristics of hash value is nothing but fixed length. Okay, it is fixed length. In SHA-256 bits we use 64 hexadecimal characters are only produced. Okay, that is the hash length. And unique representation, like even like even you can see here also only just small change, that is but uppercase h has been converted to lowercase h, and the total hash value has been changed. So it is uniquely representation. And hexadecimal format, that is the strings are from 0 to 9 and alphabets are A to F characters. Okay, then their readability. Loosely lossy compression is nothing but this. Now you can see the hash value, the output of hello, this cannot be converted again back into this, into the input hello. So that is what loosey compression is. Okay, so next is how hashing works. You can see input data. Okay, input data can be anything, a string, file, transaction, or a block. Okay, that is inputted into the hash function. Now hash function does all the processing, like it applies algorithm like padding, divides the data into blocks, and then runs the multiple rounds, and then after all the transformation we get the hash output. This is fixed length hexadecimal string. Okay, it is the length is totally based on the algorithm you are using, like you are using SHA-256 or SHA-64. Okay, whatever, that is what it is based on. And hash value. Okay, let's see, mathematical formula is hash equal to SHA-256 of data. Okay, the function is public and standardized. Anyone can compute the same hash value for the same input. Okay, so then properties of cryptographic hash functions. These are the 5 properties of hashing. That is fixed length. Okay, fixed length is nothing, that is only that whatever input, how much ever size the input you are giving, but the hash value size will be fixed. And deterministic is nothing but if you give same input multiple times, it will produce you same output, same hash value. One way function, like once the input has been converted to hash value, it can't be again reversible. Okay, avalanche effect is you just saw that h just uppercase was totally different and small lowercase has totally different. So even small change can give you great difference in the hash values. And collision resistance, like hash A will have different hash value and hash of B will have different value. So that is what collision resistance is. Like no two different will have different input data will have the same hash value. So one way hash, as I just told you, forward direction input hash, that's it. It's reverse direction, it can't be it can't happen. Okay, Avalanche effect, that is when I told you. Here you can see hello, and the change in the bits is huge. Okay, so even tiny change in the input flips the whole hash value. Okay, collision resistance. So what is collision? Like collision occurs when hash of A is equal to hash of B. As we know that two different hashes like input data can have same hash value. So if happens like that, then that is what collision have occurred. So we are using SHA-256 because it is collision resistant because what it produces 2 power 256 hash values more than the number of atoms in the observable universe. Like suppose, see, the brute force attack can be detected or hacked up to 2 power 128. So this is 2 power 256, so it is impossible and far beyond by the existence or foreseeable by no one has this capacity to do the brute force attack for 2 power 256. Okay, real world implications. So collision resistance is what makes digital signatures, certificate authorities and blockchains. Okay, so SHA-256 algorithm in blockchain. So you can see it is secure hash algorithm, 256 bit. It is a member of SHA-2 family, designed by NASA and published by NIST in 2001. Okay, it is output size is 256 bits, that is 64 hexadecimal characters. Block size is 512 chunks. Okay, and rounds are 64 rounds transformation per block. It is used in Bitcoin, Ethereum. Okay, and security level is 128-bit security against the collision attacks. Okay, like you can see, Bitcoin uses double hash SHA-256. Here's a prime example, like SHA-256 in Bitcoin. SHA-256 of block comma header. So this is how the Bitcoin uses the double SHA-256 and maintains the security in the blockchain. Okay, so why SHA-256 for blockchain? It is extremely fast. Okay, no known practical attacks after 20 plus years of scrutiny, and produces uniformly distributed outputs and well standard and openly documented. Okay, so hash linking in blockchain. So this is the block structure. Suppose like there's block 1 Genesis, like block 1 is called Genesis. It doesn't has any previous, the block which doesn't have any previous hash is called Genesis. Okay, its own hash is hash A. Now block 2 stores hash A in block 1 in its C. Suppose this is block 1, this is block 2, block 3. Okay, block 1 hash is hash A. Okay, here block 2 hash is hash B, block 3 hash is hash B. So in hash it shows hash A, hash B and hash C, but in previous hash it stores nothing. Here in previous hash it stores hash A of block 1, and here previous hash of block 3 it stores hash of block 2. Okay, you can see stores hash A in its header, its own hash is hash B. It stores hash B in its header, its own hash is hash C. Okay, what happens if data changes? Suppose block 1 hash changes from hash A to hash A1. Okay, A power 1, so A dash. Okay, blocks 2 stored reference to hash A no longer matches. Okay, block 2's own hashes become invalid and the entire system is broken. From block 2 is onward is broken. Okay, that's how the hashing achieves the tamper evidence. Okay, wherever it is changes, that time you'll know where the attack has been occurred. So role of hashing is for data integrity, security, block linking and mining. Okay, we'll know what is mining in upcoming videos. And block linking, as I told you, how it stores the previous hash of the previous block. And real world applications are blockchain security, password storage, digital signature and file integrity checking. Okay, So key takeaways is nothing but hashing converts the input data into fixed length digital fingerprint, and SHA-256 is a gold standard in blockchain. We use SHA-256 in blockchain. Avalanche effect ensures that even tiny input changes will have different hashes, and hash linking is how the blocks are connected in the chain. Okay, so once we'll have a recap. Yeah, introduction to hashing. Hash converts input data. So input data is given into the hash function, and the hash function produces the hash value. That is what the hashing is, a process of converting the input data into the hash value using a hash function. So what is hash value? Hash value is nothing but a fixed length string. The length depends totally on the algorithm you're using or the hash function you're using. Okay, and this can't be the hash value cannot be converted back into the input data. It is irreversible. And how hashing works: input data, hash function process the input data, and then hash value is produced. These are the properties of hash function: fixed length output, deterministic, one-way function, avalanche effect, and collision resistance. Okay, next SHA-256 algorithm is a secure hash algorithm that has 64 rounds and produces 64 hexadecimal characters. Okay, and Bitcoin uses double SHA-256 algorithm for proof of work mining process. So this is how hash linking happens. You can see the block 1 has no hash, block 2 stores the in previous hash value, it stores the value of block 1. Okay, so these are the rules of hashing and application. So in the next video we'll see what is Merkle tree and Merkle root. So thank you.